Hi guys, this is a very first section of notes, Chapter 1, Section 1, titled Points, Lines, and Planes. As I mentioned in class, I'd prefer it if you watch the video at home and use your time in class to practice problems. But if not, if that's not possible, or if you prefer to do it in class and practice at home, that's okay too. The main thing is to get the direct instruction, and I tend to focus most of the direct instruction on vocabulary. Okay, so this first section, points, lines, and planes, what are we going to do? We're going to be identifying points, lines, and planes in diagrams. And we're also going to focus very much on notation. That is symbolic letters on how we write points, lines, and planes. In fact, the whole course is very focused on notation. And the next set of goals is to identify what's created when two lines intersect each other and when two planes intersect each other. Alright, so starting out with vocabulary, first we're going to talk about a point. A point number one is definitely a location. And you can hear my dog barking in the back. Location. So it has neither shape nor size, and that's just something that we have to accept. And by the way, that has something in common with lines and planes. So here we call these undefined terms, and the reason why we call them undefined is because we can't really literally make a point that has no dimension, that has no shape or size. If we zoomed in here on this point over here to the right, it definitely has dimension. But the way we treat a point in geometry is that it has no dimension. So that's something that we have to take at face value. So a point is a location, and a point has no shape, no size. So you want to write that down. That's an O. And the way we notate point is capital letter. That's important. It cannot be written with lowercase letters, so please note that. Alright, so we could say, spell out this here as point A. Alright, very good. Now a line, very similar to a point, a line has no thickness at all or width. So that's why we consider it undefined. So no thickness, no width. And a line goes on forever. And that is represented in the diagram with these arrows. So a line goes on forever. And here we can name this line over here in two different ways. Symbolically, we could say that this line, and we can write out the word line, is labeled with a lowercase cursive letter. Lowercase, and you're going to see it italicized. I'm going to write cursive. And we could also name a line symbolically with 2 points that are located on the line. In this case, we have 2 points, P and Q are on that line, and we would symbolically represent that with sort of this line over the 2 letters with arrows indicating that it is a line and it's going on forever. The third term that's undefined in geometry is a plane. And a plane is considered undefined because, again, it has no dimension to it at all. So it has no thickness, and you're going to want to write that as well. A plane is a flat surface. Alright, so it's completely flat, and even though we can't show it going on forever, just like the line, we assume it is. So it's going on forever in all directions, even though in our diagram it appears to be finite. But we treat it as going on forever in all directions. And finally, how do we notate or label a plane? We can spell out the word plane and call it this, if it's labeled with a cursive capital letter. So in this case, It's a cursive K, so it's capital and it's cursive. Or you can label it with 3 non-collinear, that means 3 points that are not in a straight line. So we can label this plane BDC, and you could have just as easily said CDB or DBC, doesn't matter. What does matter is that you label it with 3 points on the plane, and those points cannot be in a straight line. So they have to be, I'm just going to write that out in words right now, and we'll talk about collinear in a sec. Not in a straight line. So you could see B, D, and C are certainly not forming a line, and we could then describe that plane with those letters. Okay, collinear, you might have already figured this out by now, but the root word co-captains, cooperate, means together. That's what that root word means. And so collinear are points that are together on the same line. So in this case, points, in our example here, points P, Q, and R are collinear because they are on the same line together. All right, very good. Coplanar are going to be points that are on the same plane. Now if you look over here in this diagram, this is showing 2 different planes. This plane here, and I know on your hard copy it's all black and white, but here on the video you can see this plane is in green and this plane is in pink. And we could describe, for instance, again together here. So points together on the same plane. And for example, on the green plane, we could say that points F, A, L, I, C, those are all coplanar because they are on the same plane. Likewise, G, E, O, and B are all coplanar. Okay, intersection. So when you think about the word intersection, I think most people probably think about roads coming together, and that would be a good connection to make. Intersection of roads is where they cross or come together. That's a simple way to think about intersection. By the way, you could think about 2 sets of numbers. Such as, let's say, whole numbers and integers, where they cross or come together or have commonality, can also be an intersection. So let's think about maybe the overlap of a Venn diagram, for instance. Commonality, the common area. So if you think of intersection in those terms, then the intersection between 2 lines, the intersection between 2 lines actually is a point. And that's always going to be the case. If 2 lines intersect, their intersection is a point. So make a note of that. In this case, I could say, I could label these L and M, and I'm going to label this point A. Now see how that A is capitalized? That is not labeling any kind of angle in there between those lines. Because it's a capital letter, we know that it's labeling the point. So in this case, the intersection between lines L and M is point A. Alright, great. In the intersection between 2 planes, this might be a little bit harder to grasp. But if you could sort of imagine these 2 planes here, Now this is always tough. Whoops, I just dropped my pen. This is always tough because this over here is trying to represent a three-dimensional thing, but it's a drawing and it's on a two-dimensional surface. But if you can imagine this blue plane is going inwards this way and the white plane is going this way, well, that intersection right here between the two is here. And it's a line, and because these planes are going on and on forever in all directions, then so is their intersection, which is a line. That's the definition of a line. So please remember that the intersection between two planes is a line. And here I could just say that the intersection between planes, I guess they're labeled A, and that's supposed to be cursive A, and cursive B is, and I'm going to just label this line L. I'm going to write that out, line L. Okay, I do want to point out, however, that the intersection between additional planes, so it is possible to have multiple planes here, in this case, not coming together or intersecting at all. That would be the case if planes were parallel. By the way, that would be the case of two planes that were parallel as well. You can have three planes coming together, in this case red, yellow, and green planes, all coming together and forming a line. I'm going to draw that here. This is a line going on and on forever. Or you can have here to the right one plane coming down here and the other two are only intersecting it, not together. They're in different locations. Same thing with down here, where in this case two lines are created. Here, 1, 2. In this case we have, I believe, 3 lines created. This one going in here, and this one going here. And then finally, these 3 planes in this diagram are all coming together at a single point. If you can imagine it, we've got this line is intersecting this line, and that is intersecting this line here. So all 3 of those lines are coming together at a point. So hopefully you can observe that. Okay, and I put together some examples here to help you with your homework. Example 1, we've got a diagram, and let's just identify some of the things that are on that diagram here. We've got a plane, cursive B. We've got 4 points on that plane. And I'm sorry, my handwriting is messy. We've got J, K, L, M. Those are all 4 distinct points. And because they're all on the same plane, we could say that those 4 points are coplanar. We've got some collinear points. J, K, L are all on the same line, and they are all on the line A. So let's use the figure to name a plane containing point L. We could call that plane cursive B, capital cursive B, or you could name it by any 3 non-collinear points. So you could say plane, for example, J, L, and M. We have to grab that M in order to define a plane. Okay, example number 2, how many planes appear in the figure? This figure again is showing a 3-dimensional object. However, it can be a little bit tricky to decode because it's on a flat surface. It's being drawn on a 2-dimensional surface. Okay, so we've got a plane S here that's shaded. And think of that as like a piece of paper or something flat. These lines here are going through the plane, and we know that because of the dash. So it's almost like this AC is a pencil going through the piece of paper here through a hole, and these dash lines are meant to show you that you can no longer see the pencil below the surface, and when it finally pops out in your vision here, it becomes solid again. Same thing with here, A, B, D. This will be another pencil. and right here is the part that you actually can't see, these dashed lines. So how many planes appear in this figure? There are 2 planes, and the plane that's easiest to see is the shaded one, plane cursive S. But we could also take a piece of paper or some kind of flat surface and make a plane out of this area here, these 2 pencils. So we can make that into a plane as long as we have 3 points that are non-collinear. We can define a plane. So the second plane here, I need to label it just with 3 points that are not forming a line. I could label this ABC, or I could label it ADC. As long as I can put together 3 points that are non-collinear, that defines a plane. Alright, using the diagram, the same diagram here on example number 3, name 3 points that are collinear. The only 3 points that are collinear in that diagram would be points A, B, and D. There are no other answers possible for that. We could say that A and C are collinear, but that is not what the requirement was to get 3 points. Using the same diagram, determine whether points A, B, C, and D are coplanar. And the answer is yes, they are. As I had mentioned above, we could take a piece of paper and we could make a plane out of that. Now here, if I put a plane on A, B, C and define that as a plane, well, a plane goes on forever, and because D is collinear with AB, then that will be on the same plane. So to explain, we would say that ABC are 3 points that are non-collinear, so they define a plane. And we can say that D is on that plane. Point D is on that plane because, and I hope you don't mind, but I'm going to abbreviate because point D is collinear with other points on that plane. I'm going to say A and B. Okay. Example number 5, using the same diagram, what is the name of the intersection between lines DB and lines CA? Well, although D and B are here, okay, line DB goes on and on forever, so it contains the entire line, and line AC, or CA, goes on forever. And so their intersection point is, well, they're always going to intersect at a point, and that point in this example is point A. And now using the same diagram, what is the name of the intersection between plane S and plane ABC? Well, where do they intersect? Where do they intersect? Their intersection, this might be a little bit difficult to see, but 2 planes always intersect at a line. If they do intersect, I should say. They could be parallel planes, in which case they would not intersect. So here, if we had this plane created by these pencils through the paper, intersecting that paper, they're going to intersect at that line, and the intersection truly is a line that goes on and on forever. Because that line is not labeled with a lowercase letter, then we need to label it with 2 points that are on that line. And so the only 2 points we can identify are B and C. And we have to indicate that it's a line with this line above it with these 2 arrows, indicating that it's going on and on forever. Example 7. How many planes appear in the figure? Well, in this figure we have the shaded plane, and that plane is T. So we have plane T, plane cursive T, and we have a plane that we can create with another piece of paper with all of these points here, A, B, R, N, Z, X. All of these will create a second plane, and it will be really only one plane because these points here are collinear, these points here are collinear. So that would create one big plane that captures all of those points that are coplanar. So the answer in this case is 2 planes. Example 8, using the diagram in number 7 above, are points X, O, and R coplanar? And the answer is yes, they are coplanar. They are collinear. Okay, so they're all collinear, forming a line, and that line is on the plane. It's on the plane T, the shaded plane. Consequently, if they're all collinear and they're all on that same plane, they must be coplanar. Okay, I hope this helps, and if you ever want to refer back to this for practice, it'll always be available on YouTube.